So I am Francesc Campoy, VP of Product and Developer Relations at Sourced, which is a company with headquarters in Madrid, but I do live here in San Francisco. So we're building tooling for large-scale analysis of source code. And that sounds pretty boring, but it is actually, our idea is to add machine learning on top of this analysis, which allows us to do predictions and build more intelligent tools, if you want. And that intelligence comes from training neural networks on huge amounts of source code. We have like a data set that we use normally, it's around 3 terabytes of source code. And then we're able to use those models that we've trained to predict a bunch of different things, and we're building an assisted code review. So it's a little bot that reviews your code before a human gets the chance to actually see it. And it's gonna detect a bunch of different things like formatting. It's also able to use a bunch of different tools that are not based on machine learning, but we also use machine learning to try to predict bugs, to correct naming, to try to figure out whether 2 pieces of code are similar enough that they should actually be merged into one. All of these different things, which are things that human reviewers normally say, but most tools do not detect at all. So it is hard to choose. I'd be in between the data pipelines and programming in general. Because what we're doing is learning from programming languages by using huge data pipelines. So we're kind of in between both. We do a lot of language analysis, we do a lot of machine learning, but we also do a lot of big data, like downloading all of GitHub into our data centers and things like this. So it's hard to choose. Both. I'm gonna go with both. So I've been sharing best practices around how to analyze source code to do machine learning. So when you think about it, source code can be seen in many different ways. One of them is obviously it's just a file, so it's made of bytes, so you can learn from those bytes, right? But then you can also use a scanner and try to learn from the tokens. So every single one of the words has more meaning than just the bytes separately. But also it's a programming language, so you can parse it and then have an abstract syntax tree. So now you can learn from trees. But also you can add extra annotations on top and say like what is defined where, semantic references. You can add control flow graphs. There's a lot of different things that are actually gonna make that tree into now a graph. So you're gonna need to learn from graphs. And basically I've been discussing a little bit the different academia research that is around this and how that research can be used to build better tooling for developers. So I've been going around today and trying to see what people are working on specifically language analysis. I think it's very interesting because every single language comes with different techniques, how to parse it, and like the type systems are very different. And coming to Scale by the Bay, I was expecting to see a lot of functional programming, which is quite different to what I normally do. I normally do more like Go and Python and languages like that. And that was actually very interesting, like seeing a little bit what people on the dark side of functional programming are working on. Okay, so I have written Scala. I actually went through I think it was Coursera or something like that with Martin Odersky. So that was a very, very good class and I really enjoyed it. Since then I haven't used Scala that much, but it was a very good first taste of what functional programming was. And after that I did go on and I learned Haskell and I learned like Clojure and things like this to try to understand a bit better. So even though Scala didn't necessarily change the way I program, it actually kind of took me into the path of Haskell, which definitely changed a lot of the way I think about programming in general. And how do I expect the world to be in 15 years in programming? I think that if my company is successful, at least, like the tooling is going to be very different, right? And hopefully we're going to be able to use machine learning not only to have the tools that allows us to better understand source code, but even to design programming languages. And I think that that's a very interesting thing, right? Like, imagine if we were able to find the best programming language for us that is strict enough that, you know, it's a programming language, it's not a natural language, but at the same time reduces the amount of not complexity, but the amount of boilerplate that we need to write. Every single programming language has boilerplate, and all of the ways we've designed programming languages so far was basically by, I mean, there's research, there's some UX studies, but it's never the thing that powers the language. Is in general, there's something else that the language is trying to do. So I would like to see that in 15 years, maybe see whether machine learning has an impact on how we design programming languages. So one of my favorite things is the fact that I actually live in San Francisco, so I just walked from home. It was like 10 minutes, so that was great. No, but I actually like the fact that in the time I've been here, it's day one, so I've actually met lots of people that were doing very interesting things, right? Not necessarily speakers, but also people in the audience. It's a very nice place to make relationships, going around, talking to people and explaining what you do. And yeah, I've met lots of interesting people. I have my pocket full of business cards, so that was very, very good, yeah. I'd say, yeah, people.